Hello everyone, this is the first chapter for the reinforced concrete structures, and first of all we are going to discuss about the cement concrete. So what is cement concrete? Concrete is a mixture of cement, water, fine aggregate and other aggregates, broken stones, which when placed in the foam and allowed to cure becomes hard like stone. The hardening is caused by the chemical reaction between the water and cement. So after the mixing of all these materials, the cement, the water and the fine aggregates and the coarse aggregate, the cement get hard after the mixing of water. The weight of the cement concrete is about 24,000 newton per cubic meter. Plain cement concrete has a high compressive strength and it is very weak in the tensile strength and is liable to crack when subjected to the tension. Thus, if beams, columns, or slabs are casted with the plain concrete, we always add reinforcement, some kind of reinforcement to give it more strength in the tensile area. Stages in the making of concrete. There are the following stages in the making of concrete: the design of the concrete for the strength and durability, selection of the material and the properties of the requesting material, mixing the ingredients of the concrete and placing it in the position, curing of the concrete. Which are the factors we are going to discuss about? Which are the factors affecting the properties of the concrete? So these are the factors which affect the properties of concrete, such as quantity of cement, size, grading, moisture of the aggregate, WC ratio, proportioning of the ingredients, method of measuring material. This is the basic factor which affect the properties of the concrete. How we measure the material, by volume or by weight. Mixing, machine mixing or hand mixing, methods adopted for the placing and compaction, and the methods for the curing. So these are the basic factors affecting the properties of the concrete. Requirement of good concrete. So what are the requirements of the good concrete? The aggregate should be hard and the durable. The aggregate should be properly graded in the size from fine to coarse. Cement should be sufficiently quantity to produce the required water tightness as a strength. The water used while mixing should be free from organic material. The water should be free from any kind of detritus or organic material. WC ratio, which is called water cement ratio, should be correct. Mixing should be done thoroughly to make concrete. This is the also the very good requirement. The concrete should be homogeneous and properly mixed. Concrete should fill every part in the formwork. So formwork is also called the shuttering. The cement, aggregate, water should be mixed in the right proportion, as the workability, strength, economy and durability depends upon the proportioning of all these ingredients. So what different grades we use in the concrete or in the concrete technology? So these are the different grades. Here is a table which grades we use in the concrete. So for ordinary concrete, M10, M15, M20, and the standard concrete M25, 30, 35, 40, 45, 50, 55, and the special type of concretes which are high strength concrete, we use M60, 65, 70, 75, 80. So here M represents the mix, and the number of the after the M represents the characteristic strength or the characteristic compressive strength of 150 mm cube at 28 days in Newton per square mm. And next is concept of the reinforced concrete. What is behind all these RCC and the concept about the RCC we produce? The tensile strength of the cement concrete is just about 10% of its compressive strength. As we already discussed about that, the concrete is very weak in the tensile strength and good in the compression strength. So basically it is 10% of the compressive strength. In other words, cement concrete is very strong in the compression and very weak in the tension. Steel is equally strong in tension and in compression. So we use basically steel for the tension and compression to increase its bearing capacity of the compressive strength, compressive forces and the tensile forces. The compressive yield strength of ordinary steel bar is about 25 times the compressive strength of the cement concrete, and the tensile strength of the steel bar is about 70 times the tensile strength of the cement. Steel bars are used to reinforce concrete flexure members to compensate for the low tensile strengths The original load carrying capacity of the cement concrete beam is very much increased by providing additional tensile strength by using steel bars. The original load carrying capacity of the cement concrete column is very much increased by providing additional compressive strength by using steel bars as a reinforcement. So it basically provides steel bars in the tension zone to increase its tensile carrying capacity, tensile load carrying capacity, and in addition we also provide steel bars in the compression zone to increase its compression carrying capacity or compressive force carrying capacity. The cement concrete reinforced with steel bars is known as RCC, and the weight of the RCC is about 25,000 Newton per cubic meter. Applications of the RCC. RCC is the mostly commonly used construction material consumed at the rate of approximately 1 ton for every living human being. RCC is used for the construction of. So basically, RCC is the one of the most used material in human being history or human being life. So what we in how many areas we use RCC? Here we will discuss about the beams, columns, slabs in residential, commercial and industrial buildings, highways and railways, water retaining structure, thermonuclear plants, aircraft hangars, marine structures, tunnel and the irrigation work, pavement for highway and airport runway, poles. Advantages of the RCC. The advantages of the RCC are it can be easily molded to any desired shape. It makes construction look very easy due to availability of the material. It is fire resistant. It is impermeable to moisture. It is durable as it can resist any action of weathering agencies. It is cheap in the long run. It can be laid in the difficult positions. It does not decay. It helps in minimizing the section of the structures as compared to the section formed with the plain concrete. It can resist the earthquakes, shock. It gives good aesthetic appearance, but there are some limitations also. So limitations of RCC are: the initial cost of the RCC is high, the dead load of the structure is increased, its construction required large quantity of the timber or steel plates for the formwork. The formwork is also called shuttering. It requires skilled labor for construction. So these are the limitations for RCC. Next we are going to discuss about the reinforcing materials. We will use different kinds of reinforcing materials for the RCC. The material which developed a good bond with the concrete in order to increase its strength is called reinforcing material. Characteristics of the reinforcing material. The reinforcing material should have following characteristics. It should be cheap and easily available. It should be durable, develop good bond with concrete. It should have high tensile strength. It should have high modulus of elasticity. It should have coefficient of linear expansion nearly same as that of concrete. It should be easy to cut, bend or weld. It should be free from loose mills, scale, loose lust, coat of paint, oil, mud, etc. So suitability of steel as reinforcing material. Why we use steel as a reinforcing material? Steel fulfills almost all the characteristics required for the reinforcing material, hence it is most suitably reinforcing material. Steel is used as a reinforcing material because of the following reason: it has high tensile strength, it is highly elastic, it can develop good bond with the concrete, it is easily available in India. So forms of the reinforced steel reinforcement. So there are different types of steel reinforcement we use in the RCC with the concrete. First of all is the mild steel plain bars. So what is the mild steel plain bars? As per conforming to the IS 432 part 1. So what is the mild steel plain bar? Mild steel is the most ductile amongst all the kind of the steel. The mild steel bars are plain, round and hot rolled. These bars have the plain surface and sufficient bond with the concrete. These bars need hook and bends at their end to anchorage. These bars are bent easily and weldable. Mild steel had definite yielding point. Plain mild steel bars, which is also known as FE 250 grade, are less commonly used for the reinforced concrete because they have less strength, or which is also called yield strength. The cost approximately the same as high strength deformed bar, which is also known as HYSD bars. However, they are used in the practice in situation where nominal reinforcement is to be provided. So next one is the high yield strength deformed bars, which is also known as HYSD bars. So these bars also have rivets or kind of ledges over it, twisted bars. These bars are obtained by subjecting the mild steel bars to cold working by tensioning and twisting. The cold working process increase both the yield as well as ultimate strength of the bars. As the name indicates, the highest yield strength deformed bars much high yield point, but the yield point is not deniable. The yield stress and the characteristic stress is given by 0.2% proof strength. So these are the how it looks like HYSD bars. It is seen that the deformed bars, there are also different kind of bars other than HYSD bars are available in the country under the patent name TORR, twisted bars, Tata and Sail, and also a steel being marked as TMT, thermally mechanically treated steel. This steel has definite yield point. It is seen that by using deformed bars TOR, the following properties are improved: considerable increase in the yield strength, increase in the tensile strength, increase in the board anchorage. So HYSD bars of the different grade and types are used. So different grades are FE415, FE500, and FE550 grade and TMT steels. So what are the advantages of the HYSD bars? Why we use the HYSD bars? Due to the high yield strength, the amount of the steel required is considerably reduced. The twisted or deformed bar provide a better bond with the concrete compared to the mild steel. During the twisting process, the defects, if any, in the mild steel are noticed and they are rejected. What are the disadvantages of the HYSD bars? With increase in the stress level, the cracking tendency increases. Hence, for FE500 or higher grade of steel, it becomes necessary to use high grade concrete. Due to the reduction in the tensile or tension steel, the design shear strength of the concrete is reduced. Mechanical properties of the different steels. So here are the table of the mechanical properties of the different kind of the steels. Here we can see the mild steel Fe250 and the characteristic strength, ultimate tensile stress, and minimum percentage of the elongation. We can also see about the Fe415 grade steel, their characteristics, their ultimate tensile strength and minimum elongation. Fe500 grade, its ultimate strength and minimum elongation. CRS 500 is its characteristic strength and 12% is minimum elongation. Nominal diameter of the bar. So what is the nominal diameter of the bar? Nominal diameter of the bar is the dimension of the diameter of the bar. The side of the square is called nominal size of the square bar. In case of deformed bar, the nominal diameter is taken equivalent to that of the plain bar having the same mass per unit length as the deformed bar. It means although the shape of the cross section of the plain and deformed bar are not equal, but the particular diameter, their cross sectional area, and the weight per meter unit length are same. The symbol phi, which may be used to indicate the nominal diameter of the bar. So different diameter of bar we use, which are 6 mm, 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 22, 25, 28, 32, and so on. So these are the properties of the round bars. These are the diameters. These are the area we can find out with the pi d square by 4, and the perimeter of all the diameter of the bars, which can we can find out with the pi d, and weights we can find out per meter length weight of different diameter of bar by d square by 162.2. This is the formula. The basic weight of the steel is taken equals to 7850 kilogram per cubic meter. And here is the table for the area of the group of bars, number of bars, and bar diameter. Next topic is loads on the structures. What kind of loads come on the structures? We will discuss about the loads. All the structures are designed for the worst combination conditions of the dead loads, live loads, wind load, seismic load, are also to be considered in the design where applicable. So first off, we will discuss about the dead load. What is the dead load? The dead load on the structure are permanent load. Dead load includes the self weight of the wall, partitions, if any, finished floor, roof. Dead load act due to gravity. Therefore, there are also known as gravity loads. Magnitude of the dead load is calculated from the unit weight of the different materials. Here is the table for the unit weight of the different materials. So we can calculate from these tables what is the dead load, and the combination of the different materials, what is the dead load of the building. And here this table continues. Next is the live load. Live load, what is the live load? Live load are either movable or moving load without any acceleration or impact. Live load on the floor and the roof shall comprise all the load which are placed temporarily, such as people, rain, table, etc. Live loads are also called the temporary loads. The different values of the live load are given in the values of the live load. So the floor load, residential, office, shops, class, restaurants, staircase, roofs, and these are the live loads we took for calculation. So the next is the wind load. The wind load is a horizontal load caused by the movement of the air relative to the earth. Wind loads have to be considered in the design of the multi-story buildings, towers and poles. So basically wind load we use wind loads for the high-rise buildings or tall buildings. Wind loads depend upon the intensity of the wind prevailing in the locality of the structure. Our country had divided into 6 zones, and the map have been prepared for the wind pressures. The basic wind pressure is, we can take it in kilonewton per square meter acting at the height over structure, may be noted from these maps given in IS 875 up to a height of 30 meter. The wind pressure is considered to act uniformly above 30 meter height. The wind pressure increases. So the next we will discuss about the snow load. So basically we calculate this snow load in the snow areas or in the mountains. The snow load are also called exceptional load as per the IS 875 1987 part 4 may be used to note value of the snow load. The snow load depend upon the latitude of the place, atmospheric humidity. Accordingly, snowfall of the place, the snow load acts vertically and it's expressed in the kilonewton per square meter. On the plain area, actual load due to the snow depends upon the shape of the roof and its capacity to retain the snow. And the next is the seismic load. It is very important load. It is also called the earthquake load. It becomes essential to consider seismic load in the design of the structure. If the structure is situated in the seismic area, the region which have experienced earthquake in the past and are likely to experience earthquake in the future, the Himalaya region, Indo-Gangetic Plain, Western India, Kutch are the places where in country which experiences earthquakes frequently. Seismic loads are caused by the shocks due to earthquake. The seismic loads shall be calculated in accordance to the 1893 IS 1893 2002. So friends, here are some of the exercise for you to conduct after all these chapters, and these are the key notes, and these are the important questions which you can discuss or can comment me in the section and ask me in the personally for any clarity. Thank you.